Welcome to today's math lesson. We're going to be working on proving that triangles are similar by finding the slope of the hypotenuse of the triangles. And so our do not for today reads Sonia and Jin are selling raffle tickets. The graph shows the relationship between the number of raffle tickets each has left to sell and the number of days they have been selling tickets. And here's our graph. Jin is this line right here, and Sonia's is this line right here. On which day does it appear that Sonia and Jin will have the same number of raffle tickets left to sell? So what we have to do is we have to identify their point of intersection, which is right here, and we're looking for the number of days that it's the same. So I'm looking for the x-coordinate of the point of intersection. So in this case, we have 12, 6. So it's 12 days, or day 12. So our answer is B. Today's TEK is 8.4a. Our lesson target is that scholars will find the slope of the hypotenuses of similar triangles to prove the triangles are similar. And our DOL is given 4 problems. Scholars will find the slope of the hypotenuses of the similar triangles to prove the triangles are similar with 100% accuracy. Some academic vocabulary words to go over before we get into today's lesson is slope, which is our change of y over our change of x. Or we can use the equation y2 minus y1 over x2 minus x1. In this case, we are comparing right triangles. So right triangles are triangles with a 90-degree angle. Similar triangles are triangles that are the same shape, but not the same size. So as you can see in this example right here, the yellow triangle and the green triangle are similar. They're the same shape, but they're obviously different sizes. The hypotenuse is the longest side of a right triangle, so it's this length right here, and that's what we're finding the slope of. It's the diagonal. So it's not the line that goes up and down or left to right, it's the line that goes at an angle. And of course, the change in y values tells us is part of our slope, as well as the change in x values. So using the slope formula, we have to find the slope of the hypotenuse of this right triangle right here, and we have to write our answer as an integer or as a fraction. So there's 2 ways to do it. I can just find 2 points and find my change in y over my change in x. So for example, my change in y would be from here to here, and so from 5 to -2, that was a change of 7. And because I'm going down and not up, it's going to be -7. So just to show you, this is -1, -2, -3, -4, -5, -6, -7. And then the change in x would be how many units we went to the right. So we went from -7 to 2, so that's going to be 9 units. And just to prove that, we went 1, 2, 3, 4, 5, 6, 7, 8, 9. So then our slope is going to be -7 over 9, and the sign of the slope is going to be negative. Another way we could have done it is found out what the coordinates of h and j are, labeled the points x1, y1, x2, y2, and subtracted. So I'm going to show that way as well. So the coordinate of h is -7, 5. And then the coordinate for j is 2, -2. So I'm going to label my points x1, y1, x2, y2. So I'm going to say -7 and 5 are x1, y1. And I'm going to say that 2 and -2 are x2, y2. Then I'm going to subtract. So we have y2 is -2 minus y1 is 5. Then we have 2 minus -7. -2 minus 5 is -7. And then 2 minus -7 when we have two negatives right next to each other, it becomes a plus or a positive. So 2 plus 7 is 9. So as you can see, using both methods, we found our slope, which was negative 7 over 9. So we have to find the slope of the hypotenuse of the right triangle. So in this case, we're moving on to finding the hypotenuse of two triangles instead of just one to verify that the triangles are similar. Because if the triangles have the same slope, that means that that's a way of proving that they're similar. So again, the hypotenuse is the longest side of a right triangle, and it's the diagonal side. And so we have two triangles right here, one that's pink and one that's purple. And it says triangle HJK and triangle KMP are similar right triangles. The coordinates of the vertices, so the vertices are the different endpoints, are integers, so it's positive or negative numbers. Determine if the slopes of the line segments HK and PK are congruent. So what we did was we labeled the points negative 7, 8 would be the point for H. Then we have to find the point for P, which is negative 1, 3. And lastly, the coordinates for K, which is 5, negative 2. Then we're going to label the points x1, y1, x2, y2. So in this case, I'm going to just say that this is x2, negative 7 is x2, 8 is y2. And I'm going to say that negative 1, 3 is x1, y1. So when I'm subtracting over here, I'm using my y2 minus y1 over x2 minus x1. So I subtracted 8 minus, so I'm actually going to label 5, negative 2 because this is the slope of the pink triangle. So over here, the 5 is going to be the x1 and the negative 2 is going to be the y1. So I have 8, which was our y2, minus our y1, which is negative 2. So we have 8 minus negative 2 on top. And then we have negative 7, which was our x2, minus 5, which was our x1. So 8 minus negative 2 becomes 10, and negative 7 minus 5 is negative 12. And if we simplify that, we get negative 5 over 6, because if we list out the factors of 5 and, or 10 and negative 12, the factors of 10 are 5 and 2, and the factors of negative 12 are negative 6 times 2, and we cross out the common factor, so the number that they have in common, which is going to be the 2, so that's how we got the negative 5 over 6. And then for the purple triangle, we found our slope. So instead of using negative 7, 8 as x2, y2, we're going to use this negative 1, 3. So the negative 1 is going to be our x2, and the 3 is going to be our y2. So then we're subtracting y2 minus y1 over x2 minus x1. Our y2 is 3. Our y1 is negative 2. So we have 3 minus negative 2. We have our x2 is negative 1 minus our x1, which is 5. So 3 minus negative 2 is 5. Negative 1 minus 5 is negative 6. And so as you can see, the slopes of the hypotenuses of the two right triangles are the same. So that proves that these two triangles are similar. Okay, this first algebra problem says triangle HJK and triangle PMK are similar right triangles. The coordinates of the vertices are integers. Determine if the slopes of the line segments HK, which is the hypotenuse of the pink triangle, and PK, which is the hypotenuse of the purple triangle, are congruent. Congruent just means the same. And so slope of HK would be the pink triangle. And so I'm going to label my points. So negative 7, 8, I'm going to say that negative 7 is x2, that 8 is y2. I'm going to say for k, I'm going to say that negative 1 is x1, and then 3 is y1. And of course, I'm going to subtract my y2 minus my y1 over my x2 minus my x1. So from here, my y2 is 8, my y1 is 3, so I'm doing 8 minus 3, which is 5. And then I have my x2, which is negative 7, minus my x1, which is negative 1. And negative 7 minus negative 1 is the same thing as negative 7 plus positive 1, and that's going to be negative 6. So we have negative 5 over 6 as our slope of the pink triangle. And then for the slope of the purple triangle, which is the slope of PK, instead of negative 1 comma 3 being x1, y1, I'm going to say that it's our x2, y2 for the purple triangle. And so that makes 5 comma negative 2 the x1 comma y1. And again, I'm going to use the equation y2 minus y1 over x2 minus x1. So y2 is 3 minus y1, which is negative 2. x2 is negative 1 minus x1, which is 5. Then we have 3 minus negative 2. 3 minus negative 2 is the same thing as 3 plus 2, which is 5. And then we have negative 1 minus positive 5, which is negative 6. So as you can see, we just proved that the triangles are similar because the slopes of the hypotenuses of the two triangles are the same. They're congruent. For this next IJU, it's very similar. So we have triangle JKL and triangle PNM are similar right triangles, and the coordinates of the vertices are integers. We have to determine if the slopes of the line segment JL, which is for the smaller pink triangle, and PM, which is for the larger purple triangle, are congruent, which means the same. So to find the slope of JL, which is for the smaller triangle, we are going to label the points for J and L. So that's negative 6 comma 5 is our coordinate for J, and 0 comma 3 is our coordinate for L. So negative 6, we're going to label x2, 5, we're going to label y2, and then 0, we're going to label x1, 3, we're going to label y1. So again, we're using the equation y2 minus y1 over x2 minus x1. So our y2 is 5, our y1 is 3, then our x2 is negative 6, and then our y1 is 0. So we have 5 minus 3, which is 2, and negative 6 minus 0, which is negative 6. If we simplify this, we're going to list out the factors of 2 and negative 6. So the factors of 2 are 2 times 1, and the factors of negative 6 are 2 times negative 3. We're going to cross out the common factor, which was the 2. So we're left with negative 1 over 3 as our slope of JL, so our slope of the hypotenuse of that pink triangle. And then for the purple triangle, which is the slope of PM, we're going to label the points for M and P. So negative 9 we're going to say is x2, 6 we're going to say is y2, 3 we're going to say is x1, P we're going to, or 2 is going to be y1. We're using the same equation y2 minus y1 over x2 minus x1. Our y2 is 6. Our y1 is 2, so we're doing 6 minus 2. Our x2 is negative 9. Our y1 is positive 3. So we have 6 minus 3, or 6 minus 2, which is 4. And then we have negative 9 minus 3, which is negative 12. Now we're going to simplify 4 over negative 12. So we're going to list out the factors of 4 as well as negative 12. So the factors of 4, I'm going to say are 4 times 1. There's other factors as well, such as 2 times 2. And then the factors of negative 12, I'm going to say are 4 times negative 3 The common factor, the number that they both have, is 4, so I'm going to cross that out. So that means that 4 over negative 12 can be simplified to 1 over negative 3, which is just negative 1/3. So as you can see, we just proved that these two triangles are similar triangles because the slopes of the hypotenuses of the triangles are congruent. There are several we do questions, and then some you do questions. And finally, your DOL, which is a 4-question quiz. And so click on this link right here to access the Google form and turn in your DOL. Thank you so much for tuning in and following along in today's lesson, and see you in the next math video.